Hello, hello. We are going to be talking about identifying lines of best fit. So when we talk about identifying a line of best fit, we're talking about scatter plots. And this is going to be a line that roughly describes the relationship that we can see in the scatter plot. So it's going to follow a general trend in the data. And what we really want to look for is that there's about the same number of points that go above the line as there are below the line. So as we can see with this scatter plot here, if we looked at the line is identified in blue, and then we can see we have about 1, 2, 3, 4, 5, 6 points above the line, and 1, 2, 3, 4, 5, 6, 7 points below the line, which is okay that we have an odd number on either side, but it is very close, okay? And that's what we want to have when we identify that line of best fit. So when we look at this example, again, we're looking for the same number of points, but in this case, the scatter plot is different. So we want to see that that line is going to generally go through the data points and have the same number on the top or the bottom. So when we look at some examples, we're going to see a couple of different examples that are showing the same set of data, but different lines of best fit that we could say that we want to pick the best one, okay? So when you look at this first one over here, we can see that the line in yellow is supposed to be our line of best fit, and it doesn't really seem to follow the trend in the data. The data seems to be increasing, and it seems to be increasing at a much more rapid rate than the line of best fit is showing us. The line of best fit is kind of, in this case, kind of a flat line that doesn't seem to go through all of the data. So we could kind of look at this and we can say this is not going to show us the line of best fit for this data. So then if we look at this example down here, we can see that this is going to be not correct, because as we said before, we said that the data seems to be increasing. If we started from left to right, so we started from this point and we looked at this point, we can see that the data is increasing. And this line of best fit is actually showing us that the data is going to be decreasing. We start from left to right and we can see that there's a general decline in the data. So we could also say that this one is not going to represent our line of best fit. Now, again, over here on this example, we have this yellow line, which is our line of best fit. We can kind of see that this one is also from left to right going to be at a slight decrease. And we know that the data is increasing. So we would say that this is also not going to represent our data in the scatter plot. Now, looking at this last example, we can see that, yes, the line of best fit is showing an increase. We start from left to right, we can see that it is increasing. And then what we want to do is we want to kind of look at the amount of points, and we want to say, okay, I have 1, 2, 3, 4, 5, 6, 7. There's about 2 points there, 8, 9, 10. 10 points on top. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one would probably count for the bottom as well. So there's 10 on the top, 10 on the bottom. This would be the best option when we are deciding what the line of best fit for this data would be. So if we look at another example, I'll clear this out. We can see we have the same set of data. And the first thing we want to identify is, with the data, do we see a general increase or decrease? So if we're talking about the data, is it going to be going up? Or if we talk about slope, is it going to have a positive slope, or is it going to be, is it going to have a negative slope or a decline or a decrease? So when we look at this data, we can kind of see that it is increasing between all of the graphs. It is the same data. So it is showing an increase if we started from this point, the furthest point left on the graph, furthest point that is closest to the origin. So right about here, and then we go to this point here that's the farthest point away from the origin. We can see that from this point to this point that we are showing an increase in the data. So that means we can kind of look at all of the lines of best fit that show a decrease. So this one appears to be showing an increase. This one appears to be showing an increase. But this one here is showing a decrease in the data. Starting from left to right, it is going down. And so we could say that this is not going to identify the line of best fit. And then also this one over here, if we start from left to right, this is also going to be showing us a decrease in the data, which we know our data is increasing. So we would say that this is not the line of best fit. So now we've kind of narrowed it down to two choices. I want to pick the one that's best, has the same amount of points as the bottom, as the top, as on the bottom. So a good thing to do is kind of just count the points. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points on the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 points on the bottom, which is okay. Again, it doesn't have to be the exact same numbers as long as it's really close. However, on this graph, we can see that this has 1, 2, 3, 4, 5, 6, about 7 points on the top, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 points on the bottom. So this one over here is not really going to show us that that is the best description of the scatter plot. It's not going to be the line of best fit. This one is actually going to work much better. So we could say that this one is not going to be correct, but then we could say that this one over here would show us a good line of best fit. Let's look at one more example here. So here the data is kind of spaced out, okay? The data is kind of spaced out, but generally looking at it, it does also look like it's increasing. It looks like if you started, and how you can tell is start at that point that's closest to the origin, then go to the point that's furthest away. We can kind of determine that from the starting point here to this point here, that it does show that it is increasing. Now, since it is increasing, it looks like all of these examples are showing the line of best fit to be increasing. What we need to do is determine which one is going to have the approximately the same amount of points on the top of the line as it's going to have on the bottom line. So if we start with this graph here and we kind of count the amount of points, we can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. But then kind of stopped here because if we see down here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It definitely seems like, and I know I did not count all of the points. Some of those points are very close together. It does look like the amount of points that are on the top of the line, there are more on the top than there are on the bottom. So that's why we want to get the best description from the line of best fit. So if we go to this one, again, we can see in this case, it looks like there are more points on the bottom of the line now. So down here than there are on top of the line. So we could assume that these two are not going to be the line of best fit. And then if we look at this one, we can see again, there's more points on the top of the line than there are on the bottom of the line. So we would say this is not going to be an example of the line of best fit. Now this last one down here looks to be very close. It looks like there are the same amount of points on the top. We can go through and we can count those. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So looking at this line of best fit, it does seem to go through the data a lot better than any of our other choices.